This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. The formula for surface area is S. I like to think of shell. Shell has 2 pi, so will surface area, then the integral from a to b, and then it's literally just arc length, so 1 plus f prime of x squared dx. The only difference is that f of x is here as well, but I like to call it r of x because I like to remember that this f of x or r of x, same thing, might be represented differently depending on the axis of rotation and the terms my equation is in. So that's my first step. I find what r of x is going to be. So if my axis of rotation is the x-axis, then that's going to depend if it's terms of x or terms of y. My equation is in terms of x because the terms are literally x, they contain x, so therefore we're going to do this option, and I'm going to take this letter, that's going to be y of x, and then this would have been y, but because it's terms of x, we're doing y of x, and y in terms of x is this. This is literally y, but in terms of x, so that's 8 square root x. Then I just like to do everything that's in here outside, so first f of x is going to be 8 square root x. I could write that as 8 to x to the 1/2. So to find f prime of x, now I can just bring that forward, so that's going to be 8 times 1/2, which is 8 divided by 2, that's 4x, and then 1/2 minus 1, you could do the math, but it's negative 1/2, and this can be rewritten as 4x to the 1/2, but this is really just square root of x. So then f prime of x squared is going to be f prime of x squared. So it's going to be 16. These cancel out, so we're just left with x, and then f prime of x squared plus 1, that's just going to be that plus 1. So then common denominator is x. This times what gives me x? 1, so 16 times 1, that's just 16. This times what gives me x? X, so it's going to have to be 1 times x, that's going to be x. So now I can plug everything into my formula. So the surface area is equal to 2 pi from a to b, and a to b is 9 to 20, of my radius, which is 8 square root x, times this, which is 16 plus x over x dx. So what I can do now is simplify, so this still is here, but then this can be rewritten as such, and then these cancel out, so I'm simply left with 8 square root 16 plus x, and because this is a constant, I can bring it out, so this is going to become 16 on the outside, because 8 times 2 is 16. Now we can find the antiderivative of this, so that's a simple u substitution, so up, so c is what we care about. I care about my u, my du, my dx, and sometimes my x. The u is going to be 16 plus x, the derivative of that is 1, that's dx. Dx is just du divided by whatever is here, so that's 1, so it's really just du, and then we don't solve for x unless we need to. Putting everything in terms of u should be a reminder that your bounds should also be in terms of u. Right now, their x is equal to 9 and x is equal to 20. So here we need to do x is equal to 20, x is equal to 9. What are the u equivalents of those values? You have an equation, plug in your x value. So that would be 16 plus 20, that would be 36, and this would be 16 plus 9. So this is 16 pi 25 36 square root u, and then dx is du, and now we can find the antiderivative of that. You could rewrite it as u to the 1/2. You add 1/2 plus 1, that's 3/2. That means you're going to divide by 3/2, or the same thing as multiplied by the reciprocal, so it's really 2/3 u to the 3/2. All this times 16 pi, and then the p part in cup is to plug your u back in. In this case, since we already have our u's, these are our u's, we plug those u's in. So that's 36 3/2, then minus 2/3 25 3/2. Recall your algebra skills. So remember that if you have x to the 1/2, we know that's square root of x, and that 1 stays next to the x, and then this on the outside is 2 because square root. Well, similarly, if you have x to the 3/2, the x and the 3 stay together, and then you do root of whatever number this is, so that's square root of x cubed. But this is equivalent to writing square root of x and then raising it to the 3rd power. So it could stay here, but it could also be out here. So in other words, when we have 36 to the 3/2, yes, this could stay here, 36 cubed, or root that, or you can write it like square root 36 and then on the outside the 3, which is so much easier. So let's go ahead and do that. We have 2/3 and then the square root of 36 all raised to the 3rd power. Square root of 36 is 6, so we just have 6 cubed, and then here 2/3, same thing, we can rewrite this as a square root of 25 raised to the 3rd power. Square root of 25, that's 5, so we have 5/3, and look at how simple this problem becomes. So 6 cubed gives you 216. We divide that by 3, that's going to give you 72, so 72 times 2, that's 144. So 5 cubed is 125, times 2, that's 250, divided by 3, or multiplied by 16 pi. And then you can just find a common denominator. It would be 3, 1 times what's 3, 3, so we're going to do 144 times 3, that's 432, and then 3 times what is 3, 1, so 1 times 250 is 250, and so this is 182 over 3, and we're multiplying this by 16 pi. 182 times 16, that's 2, 9, 12, divide that by 3, add the pi, that's your answer.